Right, so when we're finding the magnetic field from a long straight wire using the Biot-Savart law, we're looking at a wire at a distance, fixed distance, capital R, from the point that we want to know the magnetic field. And so for the Biot-Savart law, we have to use a differential element ds here. So that's a distance s from the point that's nearest to the point of the wire that's nearest to the point of interest. So we just pick one particular one and we can draw this triangle. So this r is the distance from that element to the from this element to the point. We have sine theta, which came in from taking the cross product of ds and r hat. And then we know that we can take the integral from s equals 0 to infinity and then double it. So we want to do this integral in terms of the variable s. So we need to rewrite, so as you change s, we can see that both the angle and the distance, little r, are going to change. So in order to do this integral, we need to look at our triangle. So in our triangle, we can see that from Pythagorean theorem, we have r squared is equal to, big R squared plus s squared. So that means that little r is equal to the square root of that. And then the sine of theta is the opposite over the hypotenuse. So sine theta is equal to big R over little r, which is big R over square root of r squared plus s squared. Okay, so that means that we can take this integral, I'll copy the constant, mu naught over 2 pi, and we can write this as an integral from s equals 0 to infinity. So sine theta is r over square root of big R squared plus s squared. And then 1 over r squared is going to be 1 over r squared plus s squared ds. So I can simplify this a little bit. So it's mu naught over 2 pi, integral from 0 to infinity, of r over r squared plus s squared, whole thing to the 3 halves ds. Now, this is not an integral that you can do with u substitution. If you want to look up how to do this, it's a trigonometric substitution where you can use the tangent. But what we get when we do this is that the antiderivative of this is going to be s over the square root of s squared plus big R squared, and there's a 1 over r in front that goes there, and then we're evaluating that from 0 to infinity. So the 1 over r we could pull out, so we're going to get mu naught over 2 pi r, and then if we look at, as s goes to infinity, we can say, well, we can ignore the value of r, so we have s over the square root of s squared, which is 1, and then when s equals 0, well, we have 0 divided by r, which gives us 0. So when we put that all together, we get mu naught over 2 pi r is the magnetic field. And then from the right-hand rule, we can say that on this side, if we put our thumb in the direction of the current, which is in the same direction as ds, so thumb in the direction of the current, curl our fingers around, we can say that the magnetic field is into the board. So soon we'll learn Ampere's law, which will let us do this calculation for a long straight wire much more easily.